The Sun can fit 1,300,000 Earths, but Stephenson 218 can fit 10 billion suns. If placed in the position of the Sun, Earth, Mars, Jupiter, and Saturn would all be swallowed by it, not orbiting around it, but revolving inside it. It would take 9 hours at the speed of light to barely circle it once, while orbiting the Sun only takes 14 seconds. More terrifyingly, this monster could explode at any moment, with a blast powerful enough to instantly destroy all life-bearing planets within a radius of 1,000 light-years, equivalent to 1 billion suns exploding simultaneously. Fortunately, it is far enough away from us, but astronomers have recently discovered that there may be hundreds of such ticking time bombs in the Milky Way. We just haven't found them all yet. So the question is, how did Stephenson 218 grow so large? Why is it certain to explode? If an explosion occurs, is there any possibility for humans to escape? In 1990, astronomer Stevenson discovered a dark red signal in the constellation Scuti. Initially, no one paid attention because it is 20,000 light-years away from Earth, and with the interstellar dust blocking it, it is completely invisible to the naked eye. But when the measurement results came out, the entire astronomical community was shocked. The radius of this star is 2,158 times that of the Sun, and its brightness is 440,000 times that of the Sun, breaking all records. Even more incredible is that although Stephenson 218 is enormous in size, its mass is only 18 times that of the Sun, and its average density is only 1/1,000,000th of the air at sea level on Earth. If you approach it, you will find yourself falling into an endless red mist. This is not a solid planet, but a mass of hot gas barely held together by gravity. So how did it become like this? The answer lies in the life and death cycle of stars. Stephenson 218 was born about 20 million years ago, with its core like a never-ending fusion factory, fusing millions of tons of hydrogen into helium every second, releasing enough energy to light up half of the Milky Way. But the larger the star, the faster it dies. When the core's hydrogen fuel is exhausted, a terrifying chain reaction begins. The core temperature skyrockets and it starts to burn. The outer gas expands rapidly due to the immense radiation pressure, like desperately inhaling to blow itself into a balloon. This is the red supergiant phase. Stephenson 218 is currently in this phase, and its fate is already sealed, with the core undergoing a brutal fusion relay. Helium fusing into carbon takes hundreds of thousands of years. Carbon fusing into oxygen takes a few thousand years. Oxygen fusing into silicon takes only a few years. And silicon fusing into iron takes just a few days. Each layer stacks like an onion, burning faster as it goes, with the endpoint being iron. When the core begins to synthesize iron, everything ends. Because iron is the most stable element in the universe, its fusion does not release energy but absorbs it like an engine stalling. The core will collapse in less than a second, the temperature will instantly soar to 100 billion degrees, and the outer gas will fall inward at tens of thousands of kilometers per second, then violently rebound, triggering a supernova explosion. How terrifying is this explosion? At that moment, its brightness will surpass the combined total of all the stars in the Milky Way, and the energy it releases will equal the sum of all the energy in its lifetime. The ozone layers of any planets within 1,000 light-years will be instantly stripped away by high-energy rays. Surface temperatures will soar to thousands of degrees, and all life will turn to ash within seconds. Even microorganisms deep underground will not be spared. After the explosion, the core will collapse into a black hole, with a mass so large and gravity so strong that not even light can escape. From then on, this giant star that once illuminated half of the Milky Way will forever disappear into the darkness of the universe. Fortunately, it is 20,000 light-years away from us, so even if it explodes now, the light will take 20,000 years to reach Earth. However, astronomers have found that there may be hundreds of similar red supergiants in the Milky Way. They are like ticking time bombs that could explode at any moment, and we have no idea when they will. Moreover, the status of Stephenson 218 as the largest may only be temporary. Before 2013, Scuti was the largest star, but later measurements showed it dropped out of the top 10. There is still controversy regarding the data on Stephenson 218. Some believe its true radius might only be 1,700 times, while others speculate it could be a binary star system. If it really explodes, is there a chance for humans to escape? Distance determines everything. If it is beyond 50 light-years, we are basically safe. But if a similar star explodes within 50 light-years, the gamma-ray burst would destroy the ozone layer within minutes, causing massive DNA damage to surface organisms, and we have no way to stop it. The story of Stephenson 218 reminds us that the universe was never meant for humans. We are merely the lucky ones who happen to exist at this space-time coordinate. When we gaze at the starry sky and see the beautiful starlight, it might be a farewell from a star that exploded millions of years ago. It's light traveling through time and space to finally reach your eyes. Every time we think we've reached the limit, the universe throws an even bigger mystery at us, and that's precisely what makes it so fascinating.